Number 2 from rational functions. So first thing I'm going to do is I'm going to see, can I factor the denominator? So the denominator is going to factor into x plus 3 and x plus 5 and x minus 3. And in the numerator, I can factor out a 2 to get x squared minus 16. So let me rewrite this. I know that x squared minus 16 is the same as x plus 4 and x minus 4. And this is why it is so important that you have mastered how to factor. So in order to determine the vertical asymptotes, remember our function will never cross a vertical asymptote, we're going to focus on the bottom and we're going to set each of these equal to 0 and we're going to solve. In doing so, I have a vertical asymptote and we want to write it as an equation. Vertical asymptotes cross the x-axis. So x equals negative 5 when I solve and x equals positive 3. Let me graph those. 1, 2, 3, 4, 5. And positive 3. Okay? Next, let's focus on the horizontal asymptote. Whenever the degree in the numerator, degree is the highest exponent on a variable. So whenever the degree in the numerator is equal, or equivalent, I should say, to the degree in the denominator, we're able to figure out or identify what the horizontal asymptote is by creating a ratio. We're going to take the leading coefficient in the numerator divided by the leading coefficient in the denominator. So my horizontal asymptote for this problem is 2 divided by a hidden 1. So 2 divided by 1 is 2, and we want to write it as an equation. So it's y equals 2. So I'm going to come over here and go to 2. And remember, our functions will never cross. They will never cross a vertical asymptote. They can cross a horizontal asymptote. Again, our horizontal asymptotes are going to help us when we're describing the end behavior here of our inputs. And when we look at our vertical asymptotes, we're able to see and compare our outputs at very large and very small numbers. Okay, now how do we determine what our x-intercepts are? So, excuse me, if there's a variable in the numerator, notice there's no variable in the numerator here. If there's a variable in the numerator, we're going to set that quantity equal to 0 and we're going to solve. So x plus 4 equals 0 and x minus 4 equals 0. And in doing so, I get one answer of negative 4 and another answer of positive 4. So I'm going to go to negative 4 and make a dot, and I'm going to go to positive 4 and also make a dot. Negative 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, those are my x-intercepts occurring at negative 4 and also at positive 4. How do we determine the y-intercept? When we determine the y-intercept, x is always 0. So this would be 0 squared is 0, 2 times 0 is 0. So I'd end up with a negative 32 in the numerator. Now let's look at the denominator. I would have 0 plus 0 minus 15, which would be negative 15. So this would be a negative 15. So I'd have 32 over 15. 32 over 15 would, in fact, be my y-intercept. And so we could write that down as a fraction, right? I know that 30 divided by 15 is going to give me 2, so it's going to be somewhere just a little greater than 2. So 32 divided by 15 is just a little over 2. So my y-intercept is just a little bit above 2. Well, how do we go about graphing this? So I'm going to take a value, so I can see that this rational function is going to occur down here. So I'm able to know it's going to occur down here. It's going to get closer and closer to the asymptotes. And I assume that it's going to do the exact same thing up here. So what I have here, notice I have a dot here and a dot here. So I think it's going to connect and go up this way and down this way. Well, I could choose a number. Like I can choose 1. So if I substitute in x equals 1 into this function and I can get a value, it allows me to come up with additional points that are necessary to graph it. So let me plug in 1. I have, 2 times 1 squared minus 32. This is my numerator, so I plugged in a value of 1. I come up with negative 30. And now I'm going to do the exact same thing in the denominator. So I'm going to substitute in 1. So I have 1 squared plus 2 times 1 minus 15. So this is my numerator, this is my denominator. Well, a negative divided by negative is a positive. So when I substitute in 1, I get an output of 2.5. So let's find 1 and 2.5, 1 and 2.5. So I can see that it is going up this way, it's coming back here. Okay? And now this next region, like how do I know if it's down below or if it's up above? I just have to choose a point. So here's 1, 2, 3, 4, 5. I'm going to choose anything to the left of 5. Let's try 6. So I'm going to plug in 6. Okay, so I have 2 times 6 squared minus 32. That's my numerator. And then in my denominator, I have, again, I'm plugging in, you know what? I meant to plug in -6. Let me go back. It won't make a difference for that one, but in the bottom it would. So 2 times -6 squared, subtract 32. That's my numerator. And then in the denominator, I have -6 squared plus 2 times -6 minus 15. I'm going to divide these two. So when I input in a -6, I get an answer of about 4.4. Okay, so when I input in -6, I get 4.4. 2, 4, 4.4 is right about there. And that tells me the region that this is in. And there's my rational function.